In this video, we are going to talk about acceleration of free-falling objects without air, which means in vacuum, and with air, which means air resistance is present. Students will be able to analyze speed-time graph of objects falling under the action of gravity in terms of forces acting and acceleration produced. Describe how an object under the action of gravitational force and air resistance reaches terminal velocity.
Let me first make it clear that the value of gravitational acceleration or gravitational field strength, I have taken it as 10 meters per second square or 10 Newton per kg for easy calculation, right? Consider an object that is of 10 kilogram. So if the object is of 10 kilogram, its weight will be 100 Newton by W is equal to mg, where W is equal to 10 kilogram multiplied by 10 meters per second square gravitational acceleration, so its weight is equal to 100 Newton. The air resistance acting on the object is 0 because this is the condition in which we are dropping the object without air. Resultant force acting on the object will be 100 Newton because this is the only force that is acting on the object, and since there is no force opposing this force, weight force, so 100 Newton is actually the resultant force. By the formula F is equal to ma, Newton's second law, we can find out its acceleration. A is equal to F upon m. 100 divided by 10 gives 10 meters per second square, which means this is the acceleration just after you drop the object. According to this acceleration, after 1 second, the object will gain speed of 10 meters per second because the acceleration actually tells you how much change in velocity will be per unit time. So after 1 second, it will have a velocity of 10 meters per second. There will be no change to its weight, and there will be no change to air resistance, so there will be no change to resultant force, and hence no change to acceleration. So concluding this, the object will have the same acceleration throughout its motion, which will be 10 meters per second square, or you can say after every second there will be rise in velocity of 10 meters per second for the object. So the graph will be straight line through origin. Constant gradient means constant acceleration. And also, if you drop two objects of different masses, let's say this object is of 10 kg, the other object is of 100 kg, and you drop two objects from the same point, both will hit the ground at the same time because there will be no air resistance affecting the motion. So the acceleration affecting the motion for the two objects will be same, whether the object is lighter or heavier. Now, moving on to two objects of different masses will have no effect on their motion because there is no air resistance present, so the acceleration of free fall for them will be same throughout the motion. Acceleration of free fall in the presence of air, which means air resistance now will affect the motion. Initial condition of this case is same because when the object is not moving, there is no air resistance acting on the object, so the resultant force will be same and acceleration is 10 meters per second square. After first second of fall, it will gain about 10 meters per second of velocity, and since there is increase in velocity, there will be increase in air resistance as well. The value of air resistance is, you can say, I've just taken it, you can take any value for the understanding. I've taken 20 Newton right now. So according to the resultant force calculation, 100 Newton is the force acting downward, while 20 Newton is the force which is air resistance acting upwards, so resultant force is 80 Newton and acceleration is now 8 meters per second square. As you can see by this calculation that the acceleration of the object is now less than the previous acceleration. So the object will have increase in speed, but this time the increase in speed will not be 10 meters per second, it will be 8 meters per second. So at the second of the fall, the object will have 18 meters per second, which means 8 meters per second more than 10 meters per second. Due to increase in speed, there is increase in air resistance as well. Air resistance was 20, now it is 50. So acceleration will be 5 meters per second square according to the calculation. Now the object is accelerating, but the magnitude of acceleration is less than the previous one. So the increase in velocity will also be less than previous one. At this time, the increase in velocity is 5 meters per second, and due to increase in velocity, air resistance is also more, which is 80 Newton right now. So acceleration is 20 divided by 10, because resultant force is 20. There is acceleration but less than the previous one. There will be increase in speed but less than the previous one. At this case, let's say the air resistance is 100 Newton. Now the forces acting upwards and the forces acting downwards are the same, so resultant force will be 0. If there is no resultant force, there will be no acceleration, which means the object will now not change its velocity. The velocity the object has gained will be same throughout the motion remaining, and that speed, which is maximum possible speed for an object, is actually called terminal velocity. And as you can see, the acceleration is decreasing throughout the motion of the object. Now if you want to make the graph of this, the graph will be decreasing gradient graph, because the velocity time graph gradient is actually acceleration. Since acceleration is decreasing by the time, so the gradient is decreasing by the time. At this point, the gradient is 0, which means acceleration is 0, and that constant velocity is called terminal velocity. If you want to define terminal velocity, you can write it is a maximum velocity of a free falling object when its weight and the air resistance are equal, and there is no resultant force acting on the object, and there is no acceleration produced. That's it for the concept. This video is actually for the students of O levels and A levels. Keep in mind that the value of gravitational acceleration is 9.81 for the students of AS. I have taken it as 10 because taking gravitational field strength 10 makes the calculation easy. So just to give you a clear concept, I have taken G as 10 Newton per kg, but actually it is 9.81 Newton per kg. Thanks for watching the video. Please subscribe. Air resistance is affecting the motion of feather more as compared to the ball, because the ball is heavier than feather, as you can see in this video.
So let's start solving some questions so that you have better idea how the understanding is applied, starting with the MCQ. Which graph represents the motion of a body falling vertically that reaches a terminal speed? And in this case there are 4 graphs given, and let me tell you the speed time graph. In speed time graph, the gradient of the graph, speed time graph, is acceleration. And if we are talking about terminal speed means that air resistance and the weight acting on the object both are balanced, they are equal, so there is no resultant force acting on the object. And if there is no resultant force acting on the object, according to Newton's law, if there is no resultant force acting on the object, there will be no acceleration produced. And acceleration means change in velocity per unit time. So if there is no acceleration, there will be no change in velocity, so there will be no change in speed. It means the object will fall with a constant speed. And by this understanding, only graph B is giving a correct idea, while in option A the speed is decreasing, and decrease in speed means there is resultant force acting in opposite direction to the motion, and this can only happen when air resistance becomes greater than weight, and air resistance can not be greater than weight if the object is falling with a terminal velocity. Similar is the case with option C and option D. Now moving on to the next question. Now moving on to next question. In this question, an object is falling under gravity with terminal velocity. Terminal speed or terminal velocity can be called the same, physical quantities, physical variables. So what is happening to its speed? If the object is falling with the terminal velocity means there is no resultant force acting on the object. No resultant force means there is the weight acting on of the object and the air resistance acting on the object. Both are equal in magnitude and opposite in direction. So there is no resultant force acting on the object, and since there is no resultant force acting on the object, there will be no change to its acceleration. Acceleration will be 0 because resultant force is 0, and if acceleration is 0, there will be no change to velocity. So what is happening to its speed? In option A, it's written it's decreasing. As I have told you that there is no change in velocity because acceleration is 0. So A cannot be the answer, and similar is the case with B and C. So option D is correct, because as the object is falling with terminal velocity, so terminal velocity means constant or maximum speed or 0 acceleration. So it is D in this case. Now moving on to the next question. In this question it's written 2 men jump out of an aeroplane at the same time. One of the men opens his parachute and the other man remains in free fall. Now one of the men has opened his parachute. Parachute actually increases air resistance, because the more area of the body is in contact with air, there will be more air resistance acting on the object. It's written, why is the man in free fall moving faster than the parachutist? Now in the data it is given the man in free fall is moving faster. In this question it's written the man in free fall is moving faster than the parachutist. So if the man in free fall is moving faster, so moving faster means this man has more acceleration as compared to the man with parachute. So more faster means more acceleration for the man. So more acceleration means less air resistance acting on man. So there is more upward force acting on parachutist as compared to the man, because he is not having parachute. As it is not having any parachute, so there will be no air resistance, less air resistance acting on the man. That's why the answer in C is correct, because it's written the parachutist experience greater air resistance because of greater surface area in contact with air because of this parachute. Now the speed time graph for a free falling skydiver is shown below. The skydiver alters his fall first by spreading his arms and legs and then by using a parachute. Which part of the graph shows the diver falling with terminal velocity? As I have already told you, terminal velocity means constant velocity. Constant velocity means 0 acceleration, and the gradient of the speed time graph is acceleration. So when the acceleration is 0, the gradient will be 0. Gradient at D is 0. That's why the answer is D. Next question. A small stone is dropped from the top of a ladder, falls and hits the ground. It does not rebound. Stone is actually a heavy object, so there is no significant effect of air resistance on the stone. And in the data it's written it falls and hits the ground and does not rebound, which means after striking the ground it will immediately be at rest, so it will not have any velocity in the opposite direction. So it will just after striking the ground be at rest. So according to this case, it's written stone, it's written hits the ground and does not rebound. So stone is a heavy object, so no significant effect of air resistance. Hence the only force acting is weight, and hence the constant acceleration during free fall. And it's written that it does not rebound, so after striking the ground the stone just stops and there is no velocity of the object in opposite direction. That's why the graph and the correct answer should be C. C is the correct answer. Constant acceleration, and then after striking the ground, immediately at rest, no speed, no velocity in after striking the ground. Now in this case, this is a theory question. If the same concept is asked in theory, so this is how you are going to do it. A skydiver jumps from a stationary balloon. His initial downward acceleration is 10 meters per second square. Figure 1.1 shows the directions of the air resistance and the weight of the skydiver. Air resistance is acting upwards, weight is acting downwards, and the mass of the skydiver is 60 kg and his weight is 600 Newton. So stationary balloon means the initial speed of the skydiver is 0, and if the object has 0 speed, it has 0 air resistance as well, because air resistance is a force that acts when the object is actually moving, and this is the force that opposes motion and produces heat. So when the skydiver jumps, so immediately after the fall, since it is having 0 velocity, so it will have 0 air resistance as well. So the only force acting on the skydiver at time 0 is his weight. So as you know, the acceleration is defined as the ratio between resultant force and mass. So acceleration is the ratio of resultant force and mass. So A is equal to F upon m, where F is resultant force. Since only force acting on the skydiver is his weight, so air resistance is 0 and the resultant force will be 600 Newton, the weight of the skydiver. So acceleration is equal to F upon m, where F is 600 and m is 60. So acceleration will be 10 meters per second square by the calculation. Hence the resultant force is only weight of the skydiver. So the answer is 10 meters per second square, which is the ratio of resultant force and mass in this case. Now in the next question, next part of this question, when the parachute opens, the skydiver experiences an upward acceleration for a short time. When the parachute is opened, there is more surface area of the skydiver in contact, so there will be more upward force than the downward force. So if there is more upward force than the downward force, then the resultant force will be in upward direction and the object will accelerate upwards, and this acceleration, upward acceleration, will be called deceleration, because the object is moving downwards and the acceleration is upwards, and since the acceleration and the resultant force is opposite to the direction of motion of the object, then this acceleration or force will not speed up the object, it will decelerate, or you can say the object will slow down because of this force. So air resistance is greater than the weight, so the resultant force is opposite to the direction of motion, and that's why he decelerates. In part C of this question, the same question which we are talking about, the total force of air resistance on the skydiver and the parachute changes with the speed as shown in figure 1.2. This is air resistance and this is speed. After the parachute opens, the skydiver slows down to a terminal velocity. The weight of the skydiver is 600 Newton. You have to use figure 1.2 to determine the terminal velocity of the skydiver. So what is terminal velocity? Terminal velocity is actually when the weight and the air resistance are equal. The weight in this question is given as 600 Newton. So air resistance must be equal to 600 Newton to make terminal velocity, so that the object reaches terminal velocity. So 600 Newton is weight, so air resistance must also be 600 Newton, and at 600 Newton the speed of the object is 5 meters per second. That's why this speed or this velocity will be called terminal velocity. So after the parachute opens, the skydiver slows down at a terminal velocity. The weight of the skydiver is 600 Newton. Using figure 1.2, determine the terminal velocity of the skydiver, and this terminal velocity is 5 meters per second, because by the graph which is given, At 5 meters per second, the air resistance is 600 Newton, and terminal velocity is actually the maximum velocity of an object when the air resistance and the weight are equal and there is no resultant force or acceleration acting on the object. So the answer will be 5 meters per second. Now calculate the resultant force on the skydiver when its speed is 5 meters per second. So we will go back to the graph and we will see when the speed is 5.5 meters per second, the air resistance is, according to the graph, 720 Newton, because each box on the graph is of 20, because 800 minus 600 is 200 and 200 divided by 10 boxes will give you 20 Newton for each box. So at 5.5 the air resistance is 720 Newton. So according to this we can write the resultant force is actually the sum of all the forces. So upward force is 720 Newton, downward force is 600 Newton. So the difference between the two forces, 720 Newton and 600 Newton, is 120 Newton. So 120 Newton is the resultant force acting on the skydiver. So in this video we have covered acceleration of free falling objects in vacuum and air resistance, and we have analyzed speed time graphs of objects falling under the action of gravity in terms of forces acting and the acceleration produced. And also in this video we have covered the objects that are falling under the action of gravitational force and air resistance, and they reach terminal velocity.